Hello dear students, welcome back to the study of P block elements lesson. This is the fifth part of our P block elements study. In the previous four parts, we discussed properties and uses of group number 13 elements, that's a boron family, as well as group number 14 element, that's a carbon family. Today, in this lecture, we'll study some of the important compounds of boron. The first compound of boron that we are going to study is borax with the formula Na2B4O7.10H2O. This borax is a important compound of boron element, which is a white colored crystalline solid. You can see that state of borax in this picture here. This borax dissolves in water to give an alkaline solution. Na2B4O7 plus 7H2O gives sodium hydroxide and H3BO3, Orthoboric Acid. This white colored crystalline solid that is borax, when heated, the borax first loses water molecules and swells up. Borax is in a decahydrated form, Na2B4O7.10H2O. Decahydrated form alide. When heated, it loses water molecules and swells up. When further heating, mattanu heat ಮಾಡಿದಾಗ, this borax, which is a white colored crystalline solid, turns into a transparent liquid, which upon cooling solidifies into a glass-like material that is known as borax bead. You can see in this picture, it looks like a glass, but actually it's not a glass. It's a borax bead. Na2B4O7.10H2O heat ಮಾಡಿದಾಗ, it loses water molecules, forming Na2B4O7, also called as sodium metaborate. Upon heating, it forms NaBO2, a borax bead, along with the formation of boric and hydride. This is about a few properties of borax, a compound of boron. Second compound is Orthoboric Acid, formula H3BO3. Orthoboric acid is also called as boric acid. Simple agi boric acid nu antare, Orthoboric acid nu antare. In this picture, you can see this orthoboric acid, it's a white colored crystalline solid and having a soapy to touch. Okay, when you touch this white colored crystalline solid, it's soapy to touch. Andre soap muttaga hengi jaartadalla aa riti this solid ide. This is sparingly soluble in water. Easy soluble agodilla, but highly soluble in hot water. Hot water dalli this white colored crystalline solid of orthoboric acid easily solubles in hot water. This orthoboric acid is prepared from borax. Acidification of borax, Na2B4O7, acidification ಮಾಡಿದಾಗ it form sodium chloride and BOH thrice. BOH thrice is nothing but H3BO3, Orthoboric Acid. When you look at the structure of this orthoboric acid, it's having a layered structure, okay, in which planar BO3 units, okay, these planar BO3 units are joined together by hydrogen bond. Can you see in this structure? BO3. These planar BO3 molecules are joined together through what kind of bond? Through hydrogen bond. One orthoboric acid links with another orthoboric acid through intermolecular hydrogen bonding. This orthoboric acid is a weak acid. It's a weak monobasic acid. And it's not a protonic acid. It will not dissociate to give H plus upon ionization. It's not a protonic acid, but it acts like a Lewis acid. It accepts one pair of electron. Hence, it acts like what? It acts like a Lewis acid, and it's a weak monobasic acid. And this equation BOH thrice plus 2H2O suggests that this orthoboric acid BOH thrice is a Lewis acid because it accepts a pair of electrons from water molecule. Another property of orthoboric acid is that on heating this white colored crystalline solid above 370 Kelvin, it forms metaboric acid. Orthoboric acid converted into metaboric acid HbO2, which upon further heating gives boric acid B2O3. Okay, preparation, structure, as well as few properties of orthoboric acid, another compound of boron. Third compound that we are learning is diborane. Formula B2H6. You know, it's a hydride of boron. Diborane is a hydride of boron. In hydrogen lesson, we studied that this diborane is an example of covalent hydride. It is prepared by treating boron trifluoride BF3 with lithium aluminium hydride 4BF3 plus 3Al LiAlH4 forms diborane, lithium fluoride and aluminium fluoride. Okay, that means diborane is prepared by reaction between boron trifluoride and a reducing agent lithium aluminium hydride. Structure is quite important, interesting here. The 4 terminal hydrogen atoms, that means look at this structure, the 4 terminal end hydrogen atoms and the 2 boron atom, these 2 boron atoms and the 4 terminal hydrogen atoms, they are in one plane. They lie in one plane. Whereas above and below this plane, there are 2 bridging hydrogen atoms. Can you see another one hydrogen here? One more hydrogen is here. So these 2 hydrogen atoms are bridging hydrogen atoms. Bridging hydrogen atoms, and the 4 terminal hydrogen atoms are in a one plane, whereas these 2 bridging hydrogen atoms are in another plane. It's a non-planar structure. The 4 terminal BH bonds are regular. And they are 2-centered 2-electron bond. This boron hydrogen bond is a 2-centered 2-electron bond, whereas the 2 bridged bonds are there. No, this one BHB, another one BHB. These are quite different and can be described in terms of 3-centered 2-electron bonds. So 3 centers are there, 2 boron atoms and 1 hydrogen. Totally it's a 3-centered bond and a 2-electron bond, and this hydrogens are also called bridged hydrogen. They looks like a bridge between the 2 boron atoms, no? Hence a bridged bond, which is a 3-centered 2-electron bond. So these are the third compound is a diborane. Property nododadre, it's a colorless, highly toxic gas it is. Can you see here? So this diborane, no, it's stored in a cylinder. These are diborane cylinders. It's a highly toxic gas having a boiling point of 180 Kelvin. It catches fire spontaneously, very quickly, whenever it is exposed to air. Andre ಈ ಕಲರ್ಲೆಸ್ ಗ್ಯಾಸ್ ಏರ್ ಜೊತೆ ಕಾಂಟ್ಯಾಕ್ಟ್ ಅಲ್ಲಿ ಬಂದ್ರೆ ಅದು ಫೈರ್ ಕ್ಯಾಚ್ ಆಗ್ತದೆ. ಇಟ್ ಬರ್ನ್ಸ್ ಇನ್ ಆಕ್ಸಿಜನ್ with releasing an enormous amount of energy. Look here, B2H6 plus 3O2, the diborane, a colorless gas, when comes in contact with the oxygen of the air, form B2O3 and water. Look at this value, delta H is equals to minus 1976 kilojoules per mole of energy. A lot of energy is liberated whenever diborane comes in contact with the oxygen of the air. And diborane, no, it's readily hydrolyzed in water to give boric acid. Diborane react with water forming 2 BOH thrice. BOH thrice is nothing but H3BO3. It's a Orthoboric acid along with the evolution of dihydrogen gas. This property is very important. Next one, it can be asked in the examination for 1 mark. When diborane react with ammonia, no, 3B2H6 react with ammonia plus 6NH3. It gives an inorganic compound called as borazine with the formula B3N3H6. It forms B3N3H6 ಏನಂತ ಕರೀತಾರೆ borazine along with the evolution of dihydrogen. This borazine B3N3H6 is known as inorganic benzene. You know, I studied benzene, organic chemistry ದಲ್ಲಿ formula C6H6. ಅದು ಬೆಂಜೀನ್. ಆದರೆ ಈ ಬೊರಾಜಿನ್ಗೆ ಏನಂತ ಕರೀತಾರೆ ಇನ್ಆರ್ಗ್ಯಾನಿಕ್ ಬೆಂಜೀನ್. ವೈ? Because of its ring structure. The structure of borazine looks like a benzene structure, isn't it? There are alternate BH and NH groups are there. It's also 6-membered ring. 3 members are boron and 3 members are nitrogen. And each member is linked to what? Hydrogen atom in a hexagonal ring structure. Since the structure looks like a benzene, it's called inorganic benzene. Yaudadu? Borazine. Okay, fine. These are the 3 important compounds of boron, borax, then orthoboric acid and diborane. Okay, so you can expect 1 or 2 mark question from these 3 class of compounds of boron. Okay, so in the next class we'll see some important compounds of carbon. That will be the last class of our P block elements study. Okay, thank you very much.